Hello my dear students, in this class we are going to discuss about a new type of mechanism that is to be known as SN-NGP mechanism. Okay, let us start. What do you mean by SN-NGP? How does it going to perform in the, whether it is going to be difference from the SN1 and the SN2 mechanism which are already studied in our previous classes. Let's see what do you mean by SN-NGP. Okay, SN means, we already studied about that. What is SN? SN means nucleophilic substitution, neighboring group participation. Okay, what do you mean by SN-NGP? That should be known as neighboring group participation with respect to the nucleophilic substitution, which is also known as the neighboring group mechanism, and it is also known as an anchimeric assistance reaction. Okay, basically SN mechanism is not like complete proper mechanism type of mechanism. It is only the step where it is going to deviate from the actual mechanism. Okay, let us start. How does it going to be proceed? I am taking another alkyl halide compounds, where in the alpha position I am having the leading group, in the beta position I am having an halogen group. Okay, before it is going to be, we already studied about that, halogen group is going to attack on this carbon element, that is of alpha carbon is going to attack first. That is why it is known as, it is going to be known as neighboring group. The neighboring group is going to be attacked and the bond is going to form, and there is going to be a new bond is old bond is going to be cleaved. Okay, the alpha carbon is going to have the lead group, the beta carbon is going to have the halogen element. This halogen attacking this halogen, the lone pairs are going to attack on this carbon. In this case, this halogen group is going to act on a nucleophile, where the nucleophile is going to attack on this carbon. After this, there is a formation of tricyclic structure is formed. After the formation of new bond with the halogen group and breaking of the old bond, breaking of an old bond, there is a formation of tricyclic structure. That is to be known as our tricyclic, that is known as non-classical carbocation. We already studied about what we mean by the carbocation and its reactivity. There is a formation of a tricyclic carbocation, that is carbon is going to have a delta positive charge and this carbon is also having the delta positive charge. We already know that the halogen group is to be having the delta negative. It's where this is an intermediate, that is going to be of non-classical carbocation. This is going to have the tricyclic structure which is having the ring contraction. To release the strain, we have to break any one bond here. We are going to breaking a bond here like this. Okay, we are going to, after the breaking of bond, the nucleophile is going to take place with the alpha carbon or with the beta carbon. Now, in this case, I am considering the nucleophile is going to attack on the alpha carbon. After the breakdown of the carbon, there is formation is an attention. That is which type of attacking will form? The retention type of product is formed in the case of the SN-NGP mechanism. Okay, this SN-NGP is 1000 times more reactive than the SN2 mechanism and the SN1 mechanism. Okay, what do you mean SN1? SN already studied. The rate of this mechanism is directly depend on the which type of substrate we are going to consider here. Try to remember this. The rate is directly depend on the substrate, the concentration of the substrate of the reaction. Okay, for this mechanism we are going to study the further important concept in our upcoming future class. In this class we are going to study about the next very important mechanism, that is to be known as SNI mechanism. What do you mean by SNI? SNI stands for the nucleophilic substitution internal mechanism or reaction. What do you mean by SNI? Here SNI stands for the nucleophilic substitution internal reaction. In this reaction, we are going to react with an complex, that is we are considering the compound that is of alcohol. The initial compound which is required here is, that is known as first, that is going to be of this alcohol. With alcohol alcohol, we are going to react with the thionyl chloride. We are reacting with the thionyl chloride. After reacting with, there is a formation, we are preparing an alkyl chloride complex. Alkyl chloride compound. This is a prerequisite for this reaction. Okay, this reaction is going to generate as the alkyl halide, that is of this type of product. There is a formation of the retention complex in this form. What do you mean by retention complex? Where the nucleophile, where the leaving group is going to leave, the nucleophile is going to attack on the same position. Such type of reaction to be known as the retention type of product. Let me take an example for an alcohol. Okay. Okay, this complex I am going to take here is going to react with your thionyl compound. I am going to take here thionyl compound here. Okay, the thionyl compound is going to be heated. Okay, here is I have taken the alcohol, then I have taken the thionyl chloride, and with respect to I am heating the complex in this case. Okay, the next compound, the compound after this, what is going to be prepared? How is going to prepare? Let's see. The complex is going to form like this: CH3, CH3, H, and the alcoholic group is going to replace with the chloride group, which is present in the Cl form. Okay. After this, we are going to be producing the side products. What are the side products we are going to prepare here? In this case, the side products were HCl and your sulfur dioxide. These are both the gases. I think this reaction is going to be familiar with. Why? Because in the introduction part we already studied this type of reaction. Can you name this which type of reaction it is? Definitely, this is to be known as the Darzan's process. This is to be known as Darzan's process type of reaction. I already told that this Darzan process is considered the best method to prepare the alkyl halide or alkyl chloride compounds. Why? Because it is very important type of methods. Why? Because the product which is going to form here, the side products are in the gaseous form. After the removal of gases, we are having the pure complex, that is having the pure alkyl halide. Remember this, the Darzan process is going to follow with the SNI mechanism. What is the SNI? Here SNI stands for the internal nucleophilic substitution type of mechanism. In this case, we are considering the alcohol plus thionyl chloride. We are going to form the alkyl chloride compound, which is a retention type of product here. And we are considering the alcohol, we are heating the thionyl chloride. The thionyl chloride is going to remove the alcoholic group. After leaving this, we have already studied that the thionyl chloride having the two chlorine compounds. One is going to attach in the place of the alcoholic group. The chlorine complex is going to attach in the place of the alcoholic group. That's why calling it as of our retention product. Why this is important? Why this is important? Due to the side products which these are the gaseous one. That's why we call it as this type of reaction to be known as the Darzan type of process. This reaction is known as the Darzan process. Let's see an example for it. So let us see the mechanism of the SNI. Okay, in this, as I already told that, in the case of the SNI mechanism, we are going to consider an alcohol. Here is your alcohol here. Okay, I am considering my alcohol here. I am writing in the fashion of oxygen and hydrogen bond. We already know that the oxygen is having the two lone pairs of electrons, which is going to having the higher electron density. You already know that the higher electron density will move towards the lower electron density. That's the low electron density complex, that is your thionyl chloride. Okay, this is to be known as your thionyl chloride here. Okay, I am writing in the formation of the structure. After this lone pair attack on the low electron density sulfur is there is a breaking of the bond here. The bond is going to be break here. The bond is going to break. After the breaking of the bond, we are getting a chloride ion is going to generate here. Here your chloride ion is going to generate in this case. After the rearrangement, there is a formation of the positive charge of the oxygen. After the rearrangement of the molecule, the hydrogen is having the unstable of this hydrogen bond. That's why this chlorine element is going to take down this hydrogen by the elimination of the hydrochloric acid. This is going to liberate your hydrogen chloride, that is your in the form of gas. After the removal of the hydrogen chloride, there is a rearrangement of the molecule here. What is the rearrangement here? This bond is going to shift on this sulfur bonded oxygen sulfur. The chlorine is going to attack on this carbon, highly substituted carbon. The chlorine is going to substitute here. After this rearrangement, we got the substituted chloride compound and we got the sulfur dioxide complex. This is the whole mechanism of the Darson process. Why? Because it is important. Why? Because in the case of the Darson process, we are getting the product, the side products where are both the two are in the gaseous form. This reaction follows the second order kinetics mechanism. This reaction is going to follow the second order kinetics mechanism. Okay, let me give a problem just to try yourself. As we studied the SNI mechanism, try to solve these two problems. The first one is going to having the alcohol with the phenyl group, hydrogen and the methyl group. The reagents were the thionyl chloride and heat. Try to guess the product. You have to try to solve the product here. The next problem is going to having the methyl group. This is going to be and a skeletal form. This is known as carbon, and this is going to be a CH2, and this is going to have the methyl group, which contains the alcohol and the hydrogen group. With the same reagent, that is going to be the thionyl chloride and the heat. And same again, you know, try to solve and what is guess the product. Okay, try to solve these are the very important questions for your future references. Thank you.